In this video, I'll demonstrate the difference between passing arguments to a function by value as opposed to passing them by reference using C++ code as an example. When you're passing arguments to a function by value, basically you're making a copy of the value stored in those variables and just passing that copy to the function. So the values of the original arguments remain untouched. Here's some simple C++ code of a very brief program that calls a function. As we begin to execute this program, these three variables are defined: arg1, arg2, and result. As we go through the steps of the program in this statement, arg1 receives a value of 5.0, so we see over here that this represents what's going on in memory. The memory location that stores this variable receives this value. And as we continue through the code, arg2 receives the value of 7.5, and then result receives the value calculated by the multiply function. So what actually happens at this point in the program is the program control jumps to that function, and the values of arg1 and arg2 are fetched and copied into the local variables within the multiply function called param1 and param2. And then when we do the return statement here, the two values of param1 and param2 are multiplied together to calculate the return value, and that return value is then sent back into the main program and stored in the variable called result. Now, when you're passing by reference, things happen differently. Basically, instead of passing a copy of the value, the address of the location in memory where those variables are located is passed. So it is possible for, when passing by value, for the values of those variables to actually be modified, the original variables. In C++, this is an example. We use the ampersand to indicate that we're talking about the address of the variable and not just a simple value variable. So here's basically the same program that has been modified to use the function that passes by reference rather than by value. So as we step through this program, again, we represent here the three variables that are created in the main program in memory. The value of 5 gets copied into argument 1. Argument 2 gets set to 7.5. And again, when we call the multiply function, this all looks the same as we saw before, but this is where things are different, because as we see in the function definition, we are passing the addresses of our two arguments. Therefore, we're not actually creating new variables in memory. We're just creating an alias, so to speak, where param1 is actually going to access arg1 directly, param2 is going to access arg2 directly. So it's like an alias to that address in memory. So when we calculate the return value, it's going to go directly to those places in memory, those arg1 and arg2 addresses, grab those values, calculate it, and return it. So in this example, things don't look very much different. However, if we look at another example, we can see how passing by reference can make a big difference. In this case, I've got a function that doubles the value that is passed as a parameter. So I've got my main program, I've got two variables that I'm creating in memory in my main program, assigning a value, and then calling my double function to calculate the result. And when I go down here to my function, it is fetching that parameter by reference, so it is actually grabbing the address of my parameter arg1. So it goes as an alias and goes directly to arg1. It creates it has a statement here that calculates the current value of the parameter multiplied by 2. So parameter gets the current value multiplied by 2 and stored back into the same variable. So it's actually going to change the value in arg1 and double it. And then it's going to return that value. So it's going to grab that out of arg1 and return it back. But the difference here is that our original value of arg1 actually was modified.